Hey everyone, welcome. Today we're diving into a LeetCode problem called Count Largest Group. It sounds a bit like sorting things maybe? Don't worry, we'll break it down step by step, nice and easy. Ready? Let's go. Alright, so here's the challenge. You're given a single number, let's call it. Your job is to look at all the numbers from 1 up to Pitera. For each of those numbers you need to figure out the sum of its digits. Like, if the number is 23, the sum is 2 plus 3, which is 5. Once you have the digit sum for every number from 1 to u, group them based on that sum. So, all the numbers whose digits add up to 5 go into one group, all the numbers whose digits add up to 6 go into another, and so on. Finally, you need to find out which group size is the biggest, and then tell me how many groups have that biggest size. Not the size itself, but the count of groups sharing that top size. Make sense? Let's walk through an example. Suppose is 13. Okay. We look at numbers 1 through 13. We calculate the digit sum for each one. 1 is just 1. 2 is 2. 9 is 9. 10. That's 1 plus 0, which is 1. 11 is 1 plus 1, so 2. 12 is 1 plus 2, that's 3. And 13 is 1 plus 3, which is 4. Now we group them. The numbers with digit sum 1 are 1 and 10. That group has size 2. Sum 2? That's 2 and 11. Size 2 again. Sum 3? 3 and 12. Size 2. Sum 4? 4 and 13. Also size 2. All the others, 5 through 9, only have one number each, so their group size is 1. Now, what's the largest size we found? It's 2, right? And how many groups had that size? Let's see. Sum 1, Sum 2, Sum 3, and Sum 4. That's 4 groups. So the answer for n equals 13 is 4. Okay, how can we actually do this efficiently? The core steps seem clear. First, for every single number from 1 up to the input, we absolutely must figure out the sum of its digits. No getting around that part. Then, as we calculate these sums, we need a way to keep track, like how many numbers added up to 1, how many added up to 2, and so on. We need counts for each possible sum. A hash map or a dictionary in Python sounds perfect for this. The sum is the key, and the count is the value. Once we've gone through all the numbers up to we'll have our counts. Then we just need to look through those counts, find the biggest one, the largest group size, and finally, count how many different sums actually had that biggest size. So here's the plan, step by step. First, we set up an empty container like a hash map or dictionary, ready to store our counts. The key will be the digit sum, and the value will be how many numbers resulted in that sum. Then, we start looping. We go through each number, let's call it starting from 1, all the way up to Kukor. Inside the loop, we calculate the sum of digits for. Let's say the sum is. We then find the entry for in our map, and increase its count by 1. If wasn't in the map before, we just add it with a count of 1. After we've done this for all numbers up to our map holds the size of every group. Now we look through all the counts, the values in our map, and figure out what the highest count is. Let's call this. Finally, we go through the counts in the map one more time. We simply count how many of them are equal to. That final count is our answer. Alright, here's the complete Python code that puts our plan into action. Don't worry if it looks like a lot at first glance. We've got a helper function at the top just to calculate the digit sum, and then the main part follows the steps we just discussed. We'll break down the key parts next, so it becomes crystal clear. Okay, first up is this little helper function. Its only job is to take a number and give us back the sum of its digits. It starts a sum at 0. Then, as long as the number is greater than 0, it keeps doing two things. First, it grabs the very last digit using the modulo operator. That's the remainder when you divide by 10. It adds this digit to our running sum. Second, it effectively removes that last digit from the number using integer division by 10. It repeats this until the number becomes 0, meaning we've processed all digits. Finally, it returns the total sum it calculated. Pretty neat, huh? Now for the main part. We initialize a special kind of dictionary called a default dict. This is handy, because if we try to access a key, a digit sum, that isn't there yet, it automatically creates it with a default value of 0. Perfect for counting. We also start a variable max_size at 0 to keep track of the biggest group size we've seen. Then, we loop through every number from 1 up to AA. Inside the loop we call our digit_sum helper to get the sum for. We use this sum as the key into our counts dictionary, and bump up the count. Crucially, right after updating the count, we check if this new count is bigger than our current max_size. If it is, we update max_size. This way, max_size always holds the largest group size encountered so far. Okay, almost done. After that first loop finishes, our counts dictionary has the final size for every group, every digit sum we encountered, and max_size holds the absolute largest size among them. Now, we just need to count how many groups achieved that max_size. So we initialize another counter, result_count, to 0. We then loop through all the values in our counts dictionary. These values are the group sizes. For each size, we simply check, is this size equal to our max_size? If yes, we increment result_count. After checking all the sizes, result_count holds exactly what we need, the number of groups that have the largest size. We then return that count. So how efficient is this approach? Let's think about time. We have a main loop that runs times, once for each number, from 1 to x. Inside the loop, the most significant work is calculating the digit sum. How long does that take? Well, the number of digits in a number is roughly logarithm base 10 of. So calculating the sum takes logarithmic time relative to the number itself. Since the largest number is, we can say this step takes roughly logarithm base time. Doing logarithm work times gives us a total time complexity of roughly logarithm base times logarithm. We usually write this as big O of n log n. What about memory or space? We're using that hash map to store the counts. How big can it get? The largest possible digit sum for n up to 10,000 is for 9,999, which is 9 plus 9 plus 9 plus 9 equals 36. So the number of keys in our map is actually very small and limited, regardless of within the constraints. It's technically related to log n, but practically, it's almost constant. So we can say the space complexity is big O of log n, or even big O of 1 foot, constant space, because it doesn't grow much with pretty good. Alright, let's quickly recap the main points. The goal was to group numbers from 1 to based on their digit sum, find the biggest group size, and count how many groups reached that size. The key idea was to use a hash map or dictionary. We looped through the numbers, calculated the digit sum for each, and used the map to keep track of how many numbers belong to each sum group. While doing this, we also kept an eye on the maximum group size seen so far. Finally, we just counted how many entries in our map had that maximum size. That gave us our answer. Hope that breakdown made sense and helped you understand the problem and the solution. If it did, maybe hit that like button. Subscribing for more explanations wouldn't hurt either. And if you have any questions or a different way to solve it, feel free to drop a comment below. Oh, and if you're feeling extra generous, well, the Boba Fund is always open. Keep practicing, keep coding, and I'll see you in the next video.